Hi all, welcome to the new episode of Tech Insert.
Today we are going to look on the types of electrical currents. I am sure that you all knows that there are two types of electrical current, AC and DC, and we will discuss about the terminologies, process names, etc. Most of the things are known to you all. Mainly there are four types of electrical current conversions. First one is called transformation. In transformation we are converting an AC into AC. Then what is its difference? Here the amplitude of the voltage of the transformed waveform is different. There are two types of transformations. If the voltage of the output is lower than the voltage of the input, then it is called a step down transformation. Here we are looking into the voltage of the output. If the output voltage is higher than the input voltage, then we will call it as step up transformation. And the device or equipment which will do this transformation is what we call it as transformer. I will give you an example. In your home, the line voltage is 150 volt. It is supposed to be 230 volt, but you are getting only 150 volt. One of your device at your home requires minimum 200 volt to work. Then what will you do? You will use a step up transformer to transform the 150 volt to 220 volt. Similarly, your other electronic equipment such as computer, radio, television and all those things are working on lower voltage. So you will use a step down transformer to transform the 220 volt to the required lower voltage. Now I hope you clearly understood the process called transformation and the usage of transformer. Next process name is what we call as rectification. You know, all the electronic equipments are working on DC. So what is the rectification process doing? It is converting the AC into DC. So in the rectification process, the alternating current is converted to the direct current, and the component which will do that process is what we call as rectifier. You have heard about a rectifier diodes and all. The output of the rectification process is not pure DC, it is rippled DC. We will use capacitors, inductors and all for smoothing the rippled DC to the almost DC, purest DC form. Next one is conversion. Conversion is the opposite of the transformation. What is transformation? AC to AC. Input AC will be changed to different voltage output, which is also an AC. In conversion, the input DC will be converted to different voltage DC, and the device which do this operation is called converter. There are different types of converters. If the output voltage is higher than the input voltage, then it is called DC to DC boost converter. And if the output voltage is less than the input voltage, then it is called the DC to DC buck converter. Another type is called the linear regulator. The buck converter and the linear regulator is doing the same duty. Both will regulate the output voltage with respect to the input voltage. In buck converter, they will use switching operation to regulate the output voltage. In linear regulators, it will dissipate the additional thing as heat and will regulate the output voltage. That is why efficiency is good in buck converters. TPS 5430 is an example chip for buck converter. Similarly, 78XX series or 7805, 7812 are examples of linear voltage regulators. Buck converters are costly. Next one is inversion. Inversion can be called as the opposite to the rectification. Here in inversion, what it is happening is the DC is converting to the AC, and the device which will convert the DC to AC is what we call as inverter. Not only to AC, it can be converted to any waveform, square waveform or sawtooth waveform, etc. And all these operations are not working independently, they are working as independent operation. For example, transformation. It will convert the high voltage to low voltage. Then rectification. It will convert the AC into DC, that is rippled DC. Then we will use capacitors, inductors and then smoothen the rippled DC into almost a purest DC form. Then we will give the output of the rectifier to converter or converters. That means boost converter or buck converter. If we want higher voltage, we will use boost converter. If we want lower voltage and regulated one, we will use buck converter. But the inversion operation is almost working as an independent one. In some designs, I have seen they are using a boost converter to make the voltage a bit higher. That type of designs I have seen rarely. If you believe that this theory video was helpful, then please click like button and also share this to your friends. If any of the terminologies or the things I have explained is wrong, please correct me by commenting on this video. If you really want more of this kind of video, or if you have any suggestions, then please comment on this video. Please subscribe to my channel for getting more videos like this. That will be an encouragement to me for making more things like this to you.
This is Tech Insert signing off. See you in another video. Till then, goodbye and please take care.